Hello, everyone. Welcome to the Prediction Guard MCP webinar. My name is Bing Soon, and I'm one of the AI engineers at Prediction Guard. So I'm excited to talk to you today about MCP, Model Context Protocol. We'll be diving deep into how MCP can actually enable feature-rich AI agents within your organizations. But before we get started, maybe I should just get some of the logistics out of the way and just to make sure that we like we set everyone up for just Q&A and everything. So Sharan, who's also another AI engineer in our company, he's actually helping me to manage the webinar, and he'll be feeding questions that you post. So you can actually send your questions on a chat or Q&A button and just post it on there, and Sharan will be collecting them and be sending it to me. And we will have time at the end of the webinar to be able to kind of tackle these questions as we go. Just as way of introduction, Prediction Guard as a whole, our main effort is to provide secure and sovereign AI systems for regulated industries or security-sensitive organizations. So we serve customers like the healthcare industry or even the defense industries as well, and some of the manufacturing, including agricultural, oil and gas, and just different things. We also provide education and leadership on AI's best practices. Our CEO, Daniel Whiteneck, most of you know, probably through the Practical AI podcast, he co-hosts that. And so and occasionally he also teaches that at Purdue University as well. Annually, we have actually started organizing this AI conference, which we call Midwest AI Summit, which will be happening again this year. So stay tuned on that. Make sure you get yourself signed up and don't want to miss that as well. We bring in some of the industry experts to talk about how practical aspects of implementing AI into their organizations. And so it's a very practical summit. It's not researchy, it's very relevant and very value-driven in that sense. Occasionally, we also are involved with like organizations such as ML Commons as well. You're in this webinar, we're talking about MCP, but we also have an upcoming webinar event, we call which is the semantic layer. Basically, what we're going to be talking about is how you can actually turn your fragmented organizational data into semantically searchable knowledge base. So it seems like a wordy kind of a webinar, but it's going to be really practical. It is, I don't know about you, but I'm pretty sure most of us here would understand how organizational data is usually very fragmented. You have different systems that's not really connecting to each other. How do we even connect them together? And not only that, how do we actually make them searchable in a sense you can search with meaning semantically? So don't miss on that. Register yourself for this upcoming webinar at predictionguard.com/events. You're going to find some of the events that we're involved in as well. And subsequent webinars will also be posted there, so make sure you check that page as you go. So let's get into MCP. Maybe before we do that, I would like to just take this opportunity to kind of lay out the problem statement. Why do we need MCP? You probably have already heard about it, but you're probably wondering, why do we need to have it? Perhaps this is a time that I would love to actually just kind of highlight what's been a problem statement when it comes to building AI agents at scale, especially in organizations. I call it the traditional way of connecting tools to AI agents. And the reason why I would say traditional, it's almost like it's pretty interesting, because when we say traditional, it's not something that's really old school. It's more like traditional in a sense that things that was done a year or two ago is now considered conventional and traditional, because things just move so fast. And MCP has been kind of like coming into the mainstream in the past year or so. So that's what we call a traditional way of connecting tools. And as a whole, if you're building agents, you would know that LLMs by themselves, the models such as GPT-5, Llama, Mistral, or even the latest Claude Opus 4.6, those models are powerful. But you do know that we all know that they don't contain the nuances and the business logics within your memory. All it is just some memorization of all of the web content and different data that it's been ingesting over the years. And that's about it. If your company's on it, maybe it's public data and that's it. But what about those different semantic layers or different nuances that's within your organization, different systems that you connect to? Where do you store that data? How do you access that tool? That is not available to the LLM out of the box. So to enable these LLMs to become a useful AI agent, essentially they become a useful agent. We have to either connect them to a data source or some sort of a tool so that it can actually create functions or bring value that is actually nuanced or that's actually catered to the nuances and the logics for your business. And for that, traditionally or conventionally, we would connect them with two tools, right? So imagine we have this customer success agent that we're trying to build. And then we have the CRM Salesforce. In the CRM Salesforce, we can either connect to directly or maybe create some tools, some functions that one of them is probably to create some SOQL query to execute that query to Salesforce and get direct data from Salesforce. But maybe another one you want to have a kind of like a workflow to generate some sort of a report from Salesforce. And maybe you want to also create a workflow for the agent to be able to log in as yourself into Salesforce. How do we connect that conventionally? Well, conventionally, what we would do is we would actually connect these tools by writing code blocks either with Python or Node.js, whichever language you're using, and of course with JSON strings. And what it looks like is part of that of what it looks like is we append these code blocks, these JSON strings especially, to each of the LLM calls that we're making. Every time we're calling to the LLM, we're actually carrying that information along the way. And on that kind of a JSON string that we have, you probably will have some name to describe the tool and maybe some sort of description, and then you give some sort of parameters. Is it a string that you need, date filters or integers, just different things that you might need for that particular tool, right? Excuse me. But to do that, you have to write for each of them. Each tool would have to have its own function, a Python function, or a Node or JavaScript function, and a JSON to be able to append to your LLM tool calls. So we do for each of them and the next one. So we have three tools, so we have three different code blocks that we need to maintain right here, right? Let's just take it a step further. What if we want to create a second agent, which is a sales agent, essentially does the same thing, except the difference is we're going to change some prompts, the system prompt for this sales agent. And we're saying now you're not a customer success agent, you're now a sales agent. You're going to be looking at not renewals, but you're going to be looking at leads and pipelines and stuff. But again, the tools are probably the same thing. You probably still have a query Salesforce, you probably still have some generate report, and you probably still need to log on to Salesforce. In this scenario right here, we have two agents, customer success agent and a sales agent, but we have three tools, right? But we have a boilerplate of duplicated codes of 6 code blocks itself to maintain. You could say it's not a problem, right? I mean, we're just copy and paste, right? I mean, it's exactly the same code block between these three tools for these tools. Well, what if you take it even a step further? What if you want an HR agent? Maybe the finance needs to also have an agent themselves. Then you have an nth agent right here. That brings us into, right now we still have three tools. So we have 3 code blocks for each of these tools, but we have n integration points of different agents right here. Now we have 3 times n duplicated codes right here. Probably not so bad. Again, copy paste, right? Take a step further. What if you have an M2? What if now you want to connect to your HCM system like Oracle or your HR or your ERP system like SAP, right? Or maybe your finance needs to connect to their QuickBooks. You are what you're facing now is an M times N complexity problem right here. Not only you have to maintain integration code for each of these agents, which is N of them, N agents of them, but you now would have to maintain M number of tools to connect to these different systems. This brings us to what we call the glue code trap. What it is basically gluing each of these tools to each of these agents, and it becomes a very brittle system. It probably works for a little bit, but as you scale it up, you realize that you're actually looking at a very fragile system. The moment one of these tools change, for example, maybe tool number 2 or tool number 3 changed, and all of these agents probably connect to tool number 3, then you have n times to be able to need to change the integration point for tool number 3. So APIs change, scripts break. Exponential complexity, because now you're not talking about just the number of tools, but you're talking about number of integration points. And that brings in really huge complexity that you have to maintain over different code bases. What if you didn't change one of them? What if you forgot about them? So that becomes a really, really huge maintenance cost that you have to be aware of, basically. And because it's an M times N chaotic complexity, it becomes unscalable. At some point, you're going to get tired. Your team's going to get tired, and you're going to have some shadow agent that is running somewhere, may not be running anymore because it's just not working anymore. It becomes a scalability issue. The consequence of that is that you have this agent sprawl, where you have this proliferation of different agents and tools, but it becomes an unmanaged growth because a lot of times some of these tools are some of these agents are sharing the same tools. Like, for example, sales and the go and customer success agents are probably sharing the same tools of this for the Salesforce, but you're duplicating them. Maybe team A is writing it differently than team B, right? And it becomes a duplicated effort, and it's not standardized across. And it also is a waste of compute resources. There's no central repository or central interface where you can actually look at the governance. How do you govern this? How do you know if some of these tools are safe to use? How do we know if we're actually having the right access control for our users, or quote, the agents, right? Maybe you have an HR agent that is connected to the HCM system, but it doesn't, it just pretty much shows everyone's payslip. And it's not supposed to when it's not supposed to. And so it becomes an authorization as well as a user access control problem here. Governance becomes an afterthought because it's just hard to maintain this. It's so impossible to be able to maintain systems that's so brittle and so complex at the same time. And not forgetting, we don't really have monitoring at the same time. We don't really know what each of these tools are doing because everyone is gluing their own integration points and functions and tools themselves. So what's the solution? As you can tell, that like we're talking about MCP, obviously with MCP would have been the answer to this. You probably would have seen this tweet or X post on the social media. And if some of our listeners who are from EU, you probably are aware of this, or maybe you're aware of this too, wherever you are from. But basically what happened is in January, EU has mandated that every electronic manufacturing company to use the standard USB-C interface for their charging port. It may seem trivial, but it's actually really impactful. And I think that's the case with MCP. MCP is a really simple technology that brings tremendous impact to the users as well as organizations. With just one interface now, you don't have to worry about bringing an iPad charger and an Android charger because that one charger will be able to fit into both of these different Apple versus Android interface, right? So that helps us to, it looks like we don't need to manage as many chargers. The same way for these tools through MCP, we have this standardization of managing these MCP servers or these tools that allows us to be able to, instead of following one tool is following this sort of convention and another tool is following the other convention, but agent A and agent B are not able to kind of integrate with each other, or the tools between each of these between these agents are not being able to crossbreed between agents as well. So for an MCP system itself, there are three big components. Number one, it's the LLM agent itself. So in this case, we have the customer success agent. We also have the MCP client and the MCP server. The way I like to think about it is just to give you an intuition of it. The MCP client is as if like a web browser. And we as a user, say we want to log into Gmail, or maybe we want to get onto Wikipedia, right? So Gmail and Wikipedia would have been the server that we want to access. How do we do that? How do we get a hold of gmail.com? We get to a web browser or MCP client, and the agent would have been the user, right? So we get on a browser and we type in the URL for this particular server. And what happens is the browser will create, or the MCP client will create one-to-one connection with, if authentication is needed, then it will create one-to-one connection with authentication. If not, it's just going to be able to see and explore what is on the website or on its server in a sense. So similarly, in this case, if we have a Salesforce MCP server that contains all of these tools that we talked about before, all we need is just to have that address where this Salesforce MCP server is exposed to. Then the agent will then be given that URL for this particular MCP server and will call upon an MCP client to make a connection with this. So agent by itself, as I said before, will not have any knowledge of this MCP server. Even at the point where we append, say, the URL for the MCP server, it does not know it yet until it calls upon the MCP server. And what happens is it creates that connection, and then when that connection is established, then it provides a discovery of some of these tools that happens that is available through the MCP server. Now, what are the examples of MCP clients? The For those of us who are not very technical, then maybe you are using some no-code clients. I wouldn't call it a client per se. It's more like connector, right? But within that tool, that software application, there is an MCP client that is embedded within it. For example, for Prediction Guard, we have an Agent Forge. Formerly, we call it Agent Studio. Within our Agent Forge, which is a no-code tool, for users to be able to build agents out of the box, basically. And then it's able to connect to MCP servers. So that's something that I'll be showing in a demo later. Or maybe ChatGPT Pro. So it's a chatbot, right? But the Pro subscription provides us the ability to be able to connect to any MCP server as long as you have the address and authentication that's needed that comes from it. The same goes for Cloud Pro and Klein and many other kind of coding tools, coding assistants, or chat bots, and just different things. But if your team, or if you are very technical and you're a developer yourself, then you probably will want to use endpoints, API endpoints. So Prediction Guard has endpoints that is able to call upon MCP clients as well. That's able to call upon MCP servers. The same goes for OpenAI, Anthropic, and Gemini as well. Like I said, all you need is just the URL for that server that you're connecting to. So what that looks like now is remember we had the n number of agents that we were trying to build. So now the integration point is very simple. All you need is just the URL and authentication that's needed. And you can, because it's standardized across the board, you can actually have the customer success agent and the sales agent and maybe some other agents that you're trying to build to connect to one simple interface through the MCP client, and it's able to connect to the Salesforce server. I'll tell you, I'm going to put this a little bit later within the section to show you how it decouples some of this maintenance and the development of these tools, and how it actually brings some sense in the sense of like maintaining some of the code bases and stuff. Sorry. And the same way, because we have the n number of agents, maybe you want to have a p number of server. So perhaps this is an external server. All you need, again, like I said, is this URL and authorization, and it's able to connect to any of your MCP clients. You can probably swap it around. So perhaps for the customer success agent, you want to only be able to connect to a Salesforce MCP server, but the sales agent may want to be able to connect to the same server, but also you want to allow that sales agent to have do some web search, lead enhancements and just different things as well. So, or maybe as and when you see that, oh, right now we're in a season where we need these tools, so you can put it in, you can swap it in and swap it out as you need. What that looks like is the USB-C way of standardization. And it provides that sort of a reduced failure surfaces that because the development of the MCP servers now has been decoupled from the development of your agent building. So in this layer, your users could be using, could be developing from scratch in code, or it could be using a no-code tools such as Agent Forge or even end-to-end or Langflow, and it's your users would, or your agent builders will just be mainly focused on the logics that's going within this agents that they're building without having to worry about maintaining some of these tools. And in fact, a lot of the big companies like Google, Notion, have already exposed some of the MCP servers that we can connect to and log on with our authentication as well. And because of that too, it provides us an exponential scalability in enabling agent capabilities through tools. And all of that brings in a manageable development and maintenance of agents and tools as well. The value that we're seeing from MCP, like I said, it's actually such a simple tool. It's just standardization of these tools, right? But yet the value that we're seeing is that it's actually bringing a lot of value surrounding the centralization of development. So what that looks like is the development, update, and maintenance work for the tools are now centralized at the MCP server, because now we're decoupling the agent building from the development and the maintenance of the MCP tools, the logics within, say, Salesforce. Then if there's anything that changes at the Salesforce layer for the MCP server, your agent that you built do not need to change anything, because it will be updated automatically as it discovers at the tool call time. And because of how it's standardized, the MCP clients has enabled agent builders to discover available tools without having to write boilerplate codes. Remember, we had JSON and Python codes that we have to write for each of these tools, for each of these agents. No more of that, because you have this standardization of MCP clients to be able to connect, acting like a web browser for your agents. Now, a lot of times, I think when you hear about MCP, people are always talking about the technical part, which is really exciting, as I showed you earlier. The intuition behind it is really simple, but yet it's really impactful, right? But sometimes I feel like this needs to be brought up a lot more and discussed a lot more in our sphere, in our space, where governance is really important. Now you're not only are you enabling the capabilities for these agents that you're building with tools, which is a good thing, but what about the governance? The potential of being able to connect to just any MCP server also brings in the risk of malicious attacks, prompt injections, and just different things that could come with it. The way we would like to think of it at Prediction Guard is we have this Venn diagram of application level and app platform level. And for the whole thing is, we call it the system level. And for the application level, it's pretty much the agents that we build, whether it's no-code tool or building from scratch, chatbots, workflows, just different things. And then using MCP clients to be able to connect to MCP servers. MCP servers stands in an intersection between the application and platform level, which I'll show you why later. And then moving on to the right, then we have the admin console, the control plane is what we call it internally. What this is basically you as a CEO or CTO, CISO, C-suite executives, the leaders, data leaders, AI leaders within your organization, you would want to know, how can I enable my company, my colleagues, to build their own AI agents while at the same time not having to worry about the governance, compliance issues, data security, malicious attacks, cybersecurity, just different things. We should have at least some sort of a governance surrounding the AI and MCP policies. We should also be able to somehow have some sort of approved tools and management of like allowed MCP servers or blacklist management also at the same time. But at the same time, we also would like to be able to see the system level as well. So before I get into jumping too far ahead of myself, maybe I should just go in to the application level. And so at the application level, we're talking about the agents themselves. The best practices that we would like to recommend, at least this is from our experience, is that obviously, I think it's pretty obvious, but it should be said, we should only connect to verified and trusted MCP servers. That goes without saying. We shouldn't be, it's the same thing as websites. We should not be visiting websites that we do not know or that could be, or logging into websites that we're not aware of because of phishing attacks, but it's similar concept in that sense. But at the same time, I think I've not really heard much about this in the industry, but something that is interesting that should actually be considered is to actually put some prompt injection detection layer in your tool calling or tool responses. What that looks like is, in this scenario right here, say, for example, you have a potentially compromised external MCP server that you're trying to connect to that you do not know of. Maybe it is fine, but somehow it just got compromised the last few weeks or something, and the attacker probably changed some code for tool number 2 that contains some malicious prompt injection. So your customer success agent makes a call through the MCP client to the external MCP server, and that call calls for tool number 2. What the return would have been coming back without a prompt injection layer or prompt injection detection layer would have been some sort of a prompt injection, some malicious code. It could be some context poisoning that the agent would have that would have compromised the agent as well as the users as well. But being able to put that layer before it comes back to the agent allows us to be able to detect that early, but not just to detect, but also to monitor it and to see if, to be aware that, hey, I think something is not so right with this MCP server right here. And we should probably start blacklisting it or looking into it. So that's one way to be able to know. You may not outright lock it right away, but if you see this 80% of the tool calls that come from this server has prompt injection that's been detected, then that should flag something on your system. We have that primarily or natively within our PG API. So we have a prompt injection, PII removal, just different things. I encourage you to just have a look at it. But also apart from that, Um, OpenAI has a pretty good documentation surrounding the risk and security and safety with MCP as well. So really encourage you to actually have a read, uh, go go have a look at it and just understand what kind of risk that MCPs could actually bring and how we can actually mitigate that. Now, from an application point of view for the MCP server, um, at the at the very least, we should also have some sort of authentication for these servers. And it may the industry or the MCP community recommends securing MCP servers with OAuth 2.1, and it's really extensive, a bunch of standards that they've actually put in and just different workflows that comes at the authentication level, at the transport level. It's a topic by itself that we can actually spend a whole day talking about. But I encourage you to just have a look at it. But even if you don't want to get into that granularity of a user access control with OAuth 2.1, perhaps you can actually look into just creating a static JWT token from your MCP server and have your users to use that token. At the very least, then you don't have just random users to use your resources unnecessarily. That being said, if you do want to have the granular user access control, this is pretty interesting in the sense that because it's controlled at the server, if you have the OAuth 2.1, then you perhaps would have some users, say, for example, a sales engineer wants to access this Salesforce MCP server, but the sales engineer shouldn't have the ability to be able to push any updates to Salesforce. And that is only given to, go-to-market manager or maybe account executive or whoever who may have access to that particular tool. So with an OAuth 2.1, you can actually control that sort of user access control, who gets what access to different tools that's there. Moving on to the platform level, there's an admin console and control plane that we talked about. From our side, I think our best practice, or at least our advice, would always be to aim for a unified organizational control plane for MCP governance. And not just MCP, it's actually AI governance, but MCP is one of them. At the very least, I think we should actually have some sort of a list of MCP servers that we allow in our organizations, and a list of blacklist management, a list of blacklisted MCP servers. How would we have that sort of blacklist management? Perhaps you can, as I said before, the prompt injection detection layer that you put at the application level should bring the monitoring to your control plane and to see what, among all of these MCP servers that we've been connecting to, what are the occurrences of prompt injection that's been happening from this, and those that passes a certain threshold should actually be put under blacklist server, or at least putting in a monitoring. And so the monitoring should also be happening at the control panel to be able to see from an organization. By having policies, having this list would be useless if we can't enforce it. So say we have all of these things in place, we decided we're going to allow this type of MCP servers, we're going to allow this sort of features for our users, or monitoring or anything like that. But we should actually be able to propagate all of these policies, all of these decisions, all the way down to our AI agents. And not only that, it should also be propagated to our MCP clients or our no-code tools or our API, as well as MCP servers that we have control over. So the propagation of this would actually ensure the enforcement of the decisions that we make at a unified level. So that brings us to this part where I will actually show you a live demo of what an MCP server and the governance surrounding it look like. I'm going to be using what we have over here is Agent Studio or Agent Forge. And this is something that we provide as part of our is one of our products that we're very proud of, and we just recently released, and we're constantly working on it. And you're getting a sneak preview into an unreleased feature, which is the MCP support, right? And right here, what I have is I've created some agents with this tool. With There are a lot more features to it. We have a knowledge base like RAG that you can actually have it natively. But what I want to show you right here is just basically the use of MCP server. So what I've created over here is a go-to-market Salesforce agent for a fictional company called Future Shield. And these are the models that we are hosting at our managed cloud. So we have a GPT OSS and Gemma and Llama. So I'm putting in a system prompt, your go-to-market agent for a company called Future Shield. You'll be given some MCP tools that will be useful to answer the user's queries. I should do that. Notice that I'm not putting in any more information than this. It's just the role that I'm giving to the agent. Traditionally, when we want to connect the agent to certain tools, we would append a lot of information with each tool. What do you do with this tool? What do you do with that tool? What do you need in order to use that tool in what scenarios and things like that? Right here, we're just putting in a generic but a persona-based system prompt, because we do not have to hard code some of these tool definitions to the agent anymore. And that is where I was saying it decouples agent building from maintenance and updates of the MCP servers or the tools, and it's live. So anything that changes in our MCP server will be fed directly to our agent without having us to change anything. So the cool part about this is that right now we have a non-streaming MCP capabilities. So what you're seeing over here are the tools that's being made available to our organization. So I've already registered these tools at our admin panel, and with authentications and just different tools that's being allowed from this from the Salesforce server, MCP server that we have created. And these are the tools that's been made available to me as a user in my company, right? And I'm selecting, all right, let's just use, or would like to have the agent to use this execute Salesforce query tool, generate a renewal pipeline tool, generate sales pipeline tool. That's it. I just need to choose it. And if I want to, I could actually put in some custom MCP server, maybe an external MCP server that just uses JSON and just put in some information, which is a server URL, what kind of tools are we allowing ourselves to use. And that's it. But for this demo, what we're showing is just basically tools that's been allowed at the organization level. And this is what I was also talking about, where at the organization level, you allow these tools, but you want to propagate that all the way down to your users, and then building the agents as well as the agents that's being used, that's being in deployment. There's a lot more settings that we can do. It's again a topic for another day. These are all PG prediction guard settings where it's a standard thing like temperature, top P, maximum output tokens. We can also allow file uploads. Knowledge base is basically a RAG that we have at the organization level, and we can add it and share it across different agents as well. And access control, basically, do we want to share this agent to the organization? We can also turn on prompt injection protection and PI replacement as well. In this case, we're not going to do it. But as I said, these are the tools that are native to Prediction Guard API, and it's being made available in this no-code environment. So I'm just going to just update this agent and we can try to make a call and just to see how it works. Hey there. Simple just simple chat with the agent and cool. So it's taking on the persona of a go-to-market specialist for Future Shield, right? Um, I'd like to see if it really has any purview or any access to the tools that we've exposed to them to it through that MCP server that I talked about. So maybe you can ask that, what tools do you have at your disposal? So right now it's going to query the server, and at any point, if the server changes, maybe the description changes or the parameters changes. It doesn't matter because it will just query and get a fresh discovery of those tools to the agent itself. But right now, the server has already contained all of these information, like typical use cases. What do you use for this particular tool? How do you use it? What kind of parameters? Behind the scene, it would see the parameters that it's using. Like for example, this is execute SF query, run any custom SOQL query for Salesforce data. Now, one thing is, this is connected to the real Salesforce server. So we have a developer account, and so it's kind of like a demo account. And so we created a fictional sales information data for this company called Future Shield. And so we put it up there on our Salesforce server. So maybe we can just ask, hey, can you generate the sales pipeline for 2026 since it's a go-to-market agent, right? And because it has all of these tools that it sees is being made available at its disposal, it's going to call the sales pipeline tool, and it's taking a little longer because it needs to query directly from our Salesforce server, and it comes back with the values like the 22 opportunities pipeline values, and then what's the win rate? It's 58.7%. So it gives us just the information that it the tool has created, and then brings it back to the agent itself. We could even go a little further. I'm not too sure if this is actually going to work, but we can try it. Not really. We can see. Can you generate an SOQL for the account department defense? Don't run it yet. I'd like to inspect the query. Because I'm not too sure if it actually is going to create a right query, but we'll see. We can try, right? Let's just try this. Go for it. Execute the query. So it's now calling the tool. At this point, it wasn't calling the tool, it's just generating the SOQL that it thinks it needs. And here we go. Where was it? Cool. It does work. So these are real IDs that it's mock data, but it's real ID that's on our Salesforce. And as you can see, this is actually how we can actually connect and enable the agent to use the tools that we give at its disposal. Remember one thing, my system, the system prompt that I have was really simple. It was just merely, you're a go-to-market agent for a company called Future Shield. You'll be given some tools at your disposal. And that's it, right? Everything else, how to use these tools, comes from the MCP server itself. And as you can see too over here, we are allowing ourselves to use the tools that's been made at our disposal as a user that we have access to. This is where you as a leader, AI leader in your company, you can decide maybe you want to vet through some of these tools before you make it available to your company. So you can actually set it at the admin panel or admin console or unified CX, and you can actually set that and allow your users to be able to access this at the agent building environment like Agent Forge. So just to go back to our presentation, just as a closing remark, I hope that was very clear of how MCPs can be used and how it actually provides the capabilities to the agents, to the LLMs that's beyond the memory that it has, but also creates that sort of a nuance business logics that is critical to your business that the agent may not have out of the box without these tools. So as a closing remark, we talked about traditional tool calling. There's a glue code fragility. It's a very fragile code basis that you have to maintain. There's also the complexity, n times m complexity, the number of tools and the number of models that you're maintaining. That causes some sort of that causes scalability being issues when it comes to agent building. Then we talk about how MCP can actually provide a standardization for AI agent tools. It reduces failure surfaces, but it also brings in exponential scalability in enabling agent capabilities. And it also provides a manageable development and maintenance of agents and tools because of how it decouples the integration code as well as the agent building with the maintenance of the MCP tools themselves. All that said, we should never forget governance that should be happening at all levels, whether it's at application level, platform level, or the system level itself. At the application level, remember to verify the MCP servers that we are allowing or wanting to use, make sure we know what we're connecting our agents to, and also implement prompt injection detection tools at the tool calling level. Implement industry standard authorizations like OAuth or at the very least JWAT tokens, just so that you can protect the MCP servers, but also provide RBAC, the role-based access control or granular user access control. At the platform level, we want to be able to set clear policies surrounding AI agents and MCP servers. We want to be able to have MCP allowed list, blacklist management. We also want to be able to monitor some of these, what's happening with these MCP servers, what are the responses, and are they malicious or are they safe? We should be able to do that at the platform level across our organization. But that said, we must also make sure that these policies that we set can propagate and be enforced across all levels from the AI agents, MCP clients, MCP servers as well, even at the user level. So that brings us to this point where we will answer questions. But before that, like if you have any follow-up that you want to have a chat about Prediction Guard, please do visit us at predictionguard.com/get-started. Don't forget, you can find out more about webinars or events that we'll be involved with at the events page. And do have a listen to Practical AI podcast. That's one of my favorite podcasts for AI. I've learned a lot from that even before I joined Prediction Guard. So that's definitely something you don't want to miss. We do have, just if you're curious about what we do as a company for Prediction Guard, to visit us in our website. And lastly, this is more directly related to what we're talking about. One of the pages or the community that I always go to is the Model Context Protocol.io, which is started by the Linux Foundation. It's a great resource. OAuth and all of those things, you can find out a lot about it. It's a great resource to learn and just to understand what's the latest development, latest research, latest best practices that they recommend. Definitely encourage you to check that out as well. We shall move to We shall move questions. If you have any questions, I do have one from Sharan from Shing. Would I need to know the MCP parameters to configure it? If so, where do I find resources about said parameters? Um, Appreciate um, that question, Shing. In general, if I understand correctly, when you talk about parameters, as in the tools for each of these parameters, you do not actually, if that's what you're talking about, then you actually do not need to know ahead of time what each of these tools are going to require because it will be embedded at the MCP server. At at the very least, in fact, the only thing you need to know is what is the URL for this server? If you are the MCP server developer, on the other hand, obviously you need to be able to build that server and set it up. And there's a development effort that needs to be done in there that sets up the documentation, instructions for the LLM, the parameters, and things like that. But the MCP community has done quite a great job in almost abstracting that and creating a very easy way to create MCP servers. If you use Python, FastMCP is a great package to actually use to build MCP servers. On the other hand, as a client, if you're just using some of these MCP servers that's available, then yeah, you just need to know the base URL, and that's about it. Let's see if we have any other questions. So we do have Shanzi said links to slides. Yes, we will actually be providing the slides. So for sure, just we'll email that to you. Um, do we see the MCP becoming a de facto standard across enterprise AI? I don't want to be the voice that actually determines, I don't want to speculate, but I do see that standardization is actually bringing a lot of value to the industry. And definitely MCP is one way of standardizing it. When it first came out, I cannot remember exactly when, I think it's about a year and a half ago. It was pretty well received, but there was a lot of questions on will this be adopted across the board? But over these last year and a half, we've been seeing adoption by even the big players like OpenAI, obviously Anthropic because they came out with it, and Gemini, just the mainstream players are already adopting it. So I do see that like perhaps it may actually be the standard as well. So yeah, I hope that answers it. We do have about, oh yeah, okay, more questions. How does MCP create leverage that traditional RAG pipelines fundamentally can't? Here's an interesting thing. I think RAG and MCP go together hand in hand. If you have a RAG pipeline, I would encourage you to expose that as an MCP server because then you're actually creating a resource type of MCP that agents would be able to access it. So the RAG pipeline is still very relevant. In fact, it is super relevant. The only thing is, how would you want to implement that? Would you want to implement it as part of your codes, or would you want to implement that as a server that's exposable to different people, different agents that has access to it? And all right, I think if there's no more question, I think we can call it a day. And thank you so much for joining us. I hope this was helpful to you. Do reach out to us. Do follow us on social media. Yeah, we will be sending you the recording as well as the slides very soon. reach out to us on Prediction Guard's website. We would love to hear from you. Have a good day.